Welcome back to the Comptia Network Plus course, Port Bonding. Known that almost all Ethernet networks today will typically have multiple links between switches because this kind of design provides redundancy and resiliency on a physical design that includes multiple links between switches. STP will do its job and put a port or ports into blocking mode in addition, so that routing protocols like OSPF and EtherGRP could see all these redundant links as individual ones depending on the configuration, which can mean an increase in routing overhead. We gain the benefits from multiple links between switches by using port channeling. EtherChannel is a port channel technology that was originally developed by Cisco as a switch-to-switch technique for grouping several fast Ethernet or gigabit Ethernet ports into one logical channel. Also important to note is that once your port channel is up and working, Layer 2 STP and Layer 3 routing protocols will treat those bundled links as a single one, which would stop STP from performing blocking. An additional nice result is that because the routing protocol now only see this as a single link adjacency across the link can be formed. Figure 11.2 shows how a network would look if we had 4 connections between switches before and after port channels. Now, as usual, there's the Cisco version and the IEEE version of port channel negotiation protocols to choose from, and you can take your pick. Cisco's version is called Port Aggregation Protocol, PAgP, and the IEEE 802.3 AD standard is also called Link Aggregation Control Protocol, LACP. Both versions work equally well, but the way you configure each is slightly different, keeping in mind that both PAgP and LACP are negotiation protocols and that EtherChannel can actually be statistically configured without PAgP or LACP. Still, it's better to use one of these protocols to help with compatibility issues as well to manage link additions and failures between two switches. Cisco EtherChannel allows us to bundle up to 8 active ports between switches. The links must have the same speed, duplex setting and VLAN configuration. In other words, you can't mix interface types and configurations into the same bundle. Here are a few things to remember. Port channeling bonding refers to combining 2 to 8 fast Ethernet or gigabit Ethernet ports together between two switches into one aggregated logical link to achieve more bandwidth and resiliency. EtherChannel, Cisco's proprietary term for port channeling. PAgP. This is a Cisco proprietary port channel negotiation protocol that aids in the automatic creation of EtherChannel links. All links in the bundle must match the same parameters: speed, duplex, VLAN info, and when PAgP identifies matched links, it groups the links into an EtherChannel. This is then added to STP as a single bridge port. At this point, PAgP's job is to send packets every 30 seconds to manage the links for consistency, any link additions and modifications and failures. LACP 802.3 AD. This has the exact same purpose as PAG, but it's non-proprietary, so it can work between multi-vendor networks. Device hardening. A discussion of switch security would be incomplete without discussing device hardening. Actually, this entire section is applicable to not only the routers and switches in your network, but all of the devices, including endpoints such as laptops, mobile devices and desktops. One of the ongoing goals of operations security is to ensure that all systems have been hardened to the extent that it is possible and still provide functionality. The hardening can be accomplished both on a physical and logical basis. From a logical perspective, remove unnecessary applications, disable unnecessary services, block unrequired ports, tightly control the connecting of external storage devices and media if it's allowed at all. 2 additional security features of switches. Switches really expand our flexibility when we're designing our networks. The features that we need to cover for Comptia Network Plus objectives are as follows: power over Ethernet, port mirroring, spanning local versus remote. Power over Ethernet 802.3AF, 802.3AT. Power over Ethernet PoE and PoE Plus technology describes a system for transmitting electrical power along with data to remote devices over standard twisted pair cable in an Ethernet network. This technology is useful for powering IP telephones, voice over IP or VoIP, wireless LAN access points, network cameras, remote network switches, embedded computers and other applications and other appliances, situations where it would be convenient, expensive and possibly not even feasible to supply power separately. One reason for this is that the main wiring usually must be done by qualified or licensed electricians for legal and or insurance mandates. The IEEE has created a standard PoE called 802.3AF, and for PoE Plus is referred to as 802.3AT. This standard describes precisely how a powered device is detected and also defines 2 methods for delivering power over Ethernet to a given power device. Keep in mind that the PoE Plus standard 802.3AT delivers more power than 802.3AF, which is compatible with gigabit Ethernet with 4 wire pairs at 30 watts. This process happens one of 2 ways: either by receiving the power from an Ethernet switch or other compatible device, or via a power injector, and you can't use both the approaches to get the job done, and this can lead to serious trouble, so be sure before connecting. So here we have figure 11.3, and this is I think this switch can provide power over Ethernet. As I just said, if you don't have a switch with PoE, then you can use a power injector. Figure 11.24 shows a picture of a typical power injector physically installed in a network. So here we have figure 11.4, here's our PoE switch, and here's our power injector and access point. Because most higher end switches provide PoE, we don't need to worry about injectors. But if you are adding a wireless bridge into an existing network that has switches with PoE, you need to add a power injector. Figure 11.25 shows a power injector used for a wireless bridge. So here we have a wireless bridge in here in the figure 11.25. Port mirroring spanning SPAN or RSPAN. Port mirroring, also called switch port analyzer and remote SPAN, allows you to sniff traffic on a network when using a switch. In figure 1126, you can see how a typical switch will read the forward filter table and only send traffic out destinations. This is the whole idea of using a switch. All good, but a problem with this series when you need to send traffic on the network. Figure 1126 illustrates this issue. The sniffer isn't seeing data coming from host A to host B. To solve this little snag, you can temporarily place a hub between host A and host B as demonstrated in figure 1127. This method allows you to see frames sent from host A to host B. The bad news, however, is that by doing this you'll bring down the network temporarily. The port mirroring option allows you to place a port in span mode so that every frame from host A is captured by host B and the sniffer as shown in figure 1128. This would be a helpful option to take advantage of if you were connecting an IDS or IPS to the switch as well. Be careful when using port mirroring because it can cause a lot of overhead on the switch and possibly crash your network. Because of this, it's a really good idea to use this feature at strategic times, and only for short periods if possible. Summary. In this chapter I've talked about the differences between switches and bridges and how they both work at layer 2 and create a MAC address forward filter table in order to make decisions about whether to forward or flood a frame. I also discussed problems that can occur if you have multiple links between bridges, switches, and how to solve these problems by using the spanning tree protocol STP. This chapter also introduced you to the world of virtual LANs and described how switches can use them. We talked about how VLANs break up broadcast domains in a switched inter-network. Very important, necessary thing because layer 2 switches only break up collision domains and by default all switches make up one large broadcast domain. I also described access links and went over how trunked VLANs work across a fast Ethernet link. Trunking is a crucial technology to understand well when you're reading with a network populated by multiple switches and running several VLANs. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.